Welcome. This is the third lecture in a sequence of 3 treating the topic of inheritance and related subjects in Java, and it is perhaps the most technical lecture of this course, so feel free to pause it and have a think at various stages and be reassured it gets no worse than this in this course. Okay, so we have a function makeGreeting here which gets a greeting string from an object called greeter of class hello. Okay, and then it sends a greeting to a friend. So the idea is that the greeter object is supposed to understand the message say hello, which we're going to send to it, and then we're going to add a comma, a name and an exclamation mark. Okay, and so you can see how that's used in that main method there. So what should be in the hello class? Well, here is a really trivial example of a hello class. Its say hello method simply returns the string hello, and if that's the one we use, then that's the output we'll get from the program we saw earlier. But suppose that we would like to go international now, and we would like to add a new class called bonjour. And the idea here is that it should do the equivalent thing in French, and so perhaps the most natural follow-your-nose type thing is to say we'll have a public class bonjour, but we'll change the method name, so this one will have dis bonjour, and it will return bonjour. But the trouble is, we would like both of these classes to be used in a uniform way by our same makeGreeting method. But this doesn't really work. So we might sort of think about whether we can do this just by kind of duplicating code. So we can have a go at that, but it won't work, will it? Because the fruit greeter doesn't understand the say hello message. So we would have to overload the makeGreeting method as well. So now we're really duplicating code like crazy. We've got 2 versions of makeGreeting, one of which understands a hello object and the other of which understands a bonjour object. And that just seems a bit silly, doesn't it? So the question is, can we somehow create a more general version of makeGreeting which can use a hello object or a bonjour object depending on what the client wanted to send it? And the first step in achieving this is to give both of those classes, hello and bonjour, a common API. In other words, they should use the same methods. So we'll give both of those classes a method greet. We will make them understand the message greet. It's just that they return different strings on being sent that message. That's a good step in the right direction. But what can we say what the shared API between these 2 classes is? We would like to do this in order that we can extend to other languages in future, for example to enforce that a new class, buongiorno, should conform to the same API. Well, you might think the next thing we could do is to pull that API into a superclass, and we might call that greeting, and that works fine. Okay, so now we can have our 2 classes, hello and bonjour, we can make them both extend greeting and implement it differently. And then we need to refactor the makeGreeting method so that rather than assuming that it knows whether it's getting a hello or a bonjour, it can use any object that implements greeting. And we can do that using polymorphism, as we saw before. And this is how this might work. It's very similar to what we did before. We are just sending the greeting object its greet message. And then we can create 2 different objects of concrete subclasses of the class greeting, and we can send them both to the makeGreeting method, and all is well. But what happens if we do this? Now in this case we are just simply creating a greeting object, not of one of the subclasses that we know about, but just a general greeting object. Now what on earth should that do? It doesn't know what language to speak in. There's not really any sensible implementation of the greet method for a greeting class which hasn't specified what language it's supposed to greet in. So what we do instead is we declare the greeting class to be an abstract class. And really what that means is we don't know exactly how to implement the behaviour of this class. The class is there in order to have concrete subclasses that will know how to implement their behaviour. And in particular, we don't know how to provide an implementation for greet, and so we declare the greet method abstract as well. So you see the same keyword is being used in two different contexts here, once to apply to the class and the other time to apply to the method. When you have an abstract method, you do not provide an implementation in curly brackets as you're used to doing. Instead, you simply put a semicolon after that specification of what the method is. That's good. That actually solves our problem. So, what about abstract classes? They cannot be instantiated. That's the whole point. So if you try to instantiate an abstract class, you get a compiler error. The compiler knows that you cannot instantiate an abstract class. That's good. But the point of having an abstract method is that it enforces the required API for each subclass. If you want to have a subclass that can be instantiated, then you must provide an implementation for each abstract method. So, for example, this is what we do. Similarly, we might think about the animal class that we previously created as an abstract superclass for all of our specific classes representing different kinds of animals. Suppose we tried to directly instantiate an animal object. Well, that doesn't really make much sense. What kind of animal should we instantiate? So animal 2 should be an abstract class. And here is a summary of what we now know about abstract classes versus concrete classes. And here is an abstract class animal. Now, notice that our abstract class animal does in fact provide implementations of each of the three methods we have. There's no particular need for an abstract class to have any abstract method, although it can. If you have an abstract method in a class, then the class must be abstract, but not the other way round. An abstract class can be extended by other abstract classes, for example, canine and feline. Those should also be abstract. And we could make the methods abstract if we wished to. That's absolutely fine. It's up to us. It depends really on whether there is or is not a sensible default implementation. If there is a sensible default implementation, then it makes sense to make that be the implementation in the abstract class. If there isn't one, then don't put one. Any abstract method must be implemented in any concrete subclass, otherwise the compiler will complain. Yes, nothing more to say about that, I don't think. Right. And so here we have the animal hierarchy showing the abstract classes. There's actually a tiny UML error in this, but I will leave that as an exercise for the truly pedantic. So you use an abstract class when you have several similar classes that have quite a lot in common, but have some differences. Let's look at some examples. What does this print? As per usual, have a think. When you think you know, proceed. This doesn't compile because abstract classes cannot be instantiated, and here we are trying to instantiate the abstract class vehicle. What about this one? This one doesn't compile because the abstract methods, for example drive, must be implemented in a subclass, otherwise the subclass can't be concrete, can't be instantiated. What about this one? This one prints roll. So in this case everything's fine. We have car, which extends vehicle, implements vehicle's one abstract method, and then Polo inherits that implementation and everything works fine. So abstract classes are one very important way of handling this issue in Java, that you might have identified a common conceptual superclass of some classes, but you might not be in a position to provide sensible implementations of all of its methods. The other mechanism that it's important to know about, which is closely related, is interfaces. So suppose we have different types of cars. We have instances of class VW Polo, which are all instances of petrol car, and we have instances of Tesla S, which are all instances of electric car. And petrol cars have a method refill tank, and electric cars have a method recharge battery. How should we handle a so-called plug-in hybrid which has both battery and petrol? In other words, it has features of both superclasses. Well, you could create a new superclass that has both methods with simply no relationship between that new superclass and the superclasses petrol car and electric car. And that would have some problems. It would be wasteful, it would give you code duplication, both in these classes and, more importantly, in any client that is trying to interact with all three kinds of cars. So what else could we do? Well, you might think it would be sensible, wouldn't it, to have our Chevrolet Volt car class inherit from both petrol car and electric car, and thereby inherit both of the relevant methods, refill tank and recharge battery. And that's a decent idea, but unfortunately, as was found through long experience in C++, multiple inheritance, having one class that inherits from multiple superclasses, gives you some painful problems. And this is the classic diagram called here the deadly diamond of death. So fundamentally the issue is, if you inherit a method via two different routes, and somewhere on each of those two different routes the method is overridden, then which overriding version should your multiply inheriting class use? So C++ has mechanisms to resolve ambiguity in such cases, but actually long experience with C++ convinced experts in C++, including I think the developer of C++, that this was really a mistake, and that's why Java doesn't do it. So instead, Java forbids multiple inheritance, but instead it provides something which gives you almost all of the benefit, but very little of the pain of multiple inheritance, namely interfaces. So what are interfaces in Java? They're very like classes, except that instead of the word class you use the word interface. They are very like abstract classes in the sense that they are things that behave like types, so they're very much like classes, but they cannot be instantiated. The difference is they're kind of like fully abstract classes. So in an interface, all methods have to be abstract. So here we have two different interfaces, one representing petrol cars and the other representing electric cars. Now it turns out that because these interfaces do not allow any sharing of implementations, they allow us to inherit from multiple ones of them without getting us into the problems which, recall, related to sharing implementations via more than one route that were the problem with multiple inheritance. And this is how they solve the problem. They enforce an API. So we can do it like this. We can have a class which implements interfaces. It can implement one interface, it can implement multiple interfaces. And when you say that your class, for example Chevrolet Volt, implements an interface, the compiler will check that it really does. In other words, any method which is specified in the interface petrol car must in fact be provided with an implementation inside the class Chevrolet Volt. And you can both extend a class and implement an interface, so this can get as complicated as you need it to get, although always remember, never make it more complicated than it needs to be. And we have some syntactic sugar, which is quite convenient for interfaces in Java. So, Java enforces that all methods in an interface must be public. If you think about it, it doesn't really make sense to have private methods in an interface, because the point about a private interface is that it encapsulates private data, but interfaces don't have data anyway. So all methods must be public, and therefore you don't have to say so. You can just call them abstract methods like that. But also, we already said all methods must be abstract, so we don't have to say that either. We can omit that specification. And it's just because the Java language already knows that these things are public and abstract, just because it knows it's an interface, so you don't have to say so again. No constructors are allowed. Now, what about data members? Data members are in fact allowed, but they have to be public static final. So this is the kind of thing you can say. So we can say that we've got essentially a fixed constant fuel, which it just represents the string diesel, if we feel like saying that. That's allowed. Because they have to be public static final, you don't have to say so. So we can just specify their type, their name, and their initial value. That's fine. Okay. So now, when we use these interfaces, in principle we have to implement refill tank and recharge battery for each new superclass. In practice, in Java you probably wouldn't do that. What you would probably do instead would be to use object composition, and it might look something like this. What you might say is that your Chevrolet Volt has an object reference to a thing of class battery charger and an object reference to a thing of class fuel pump, and then it simply uses those using their interfaces in order to implement these methods, which it is required to implement in order to satisfy these interfaces, petrol car and electric car. And in fact, in general, I said before, I think, that newcomers to object orientation often overuse inheritance. The thing they underuse is composition. Generally speaking, composition gives you looser coupling between your classes and more flexibility, and is a better idea, even though it's in some ways less exciting than using inheritance. Now you can have a browse around the Java JDK, the Java API, to see how inheritance is used in the library. This time I've given you a URL to Java 15, I think just because the one I replaced was Java 8 and that seemed ridiculously old. But like I said before, there are different URLs to different versions of Java in this slide set, and you should go to whichever version you're using right now, and you might like to have a look at different versions and see what's changed and what hasn't. Okay. Now we're going to talk about something slightly different. We're going to talk about the comparable interface. So let's motivate this by, again, a slightly artificial example. Suppose we have an array list of cows, of objects of class cow, and we would like to be able to order them by size. So suppose our cow class extends the animal class that you've seen before by these three private attributes: size, milk yield, and name. Okay. Now you want to sort them by size. Okay. So we have our array list of cows, and we're going to form a collection of cows by some means we don't need to go into. And then, having formed an array list of cows, we're going to sort it using the sort method from the JDK's collections class. But how are we going to sort it? There are several different ways we could sort cows. We could sort them by size, or we could sort them by milk yield, or we could sort them by name. How is the sort method going to know which of those different reasonable orderings you actually mean in this line in your code? Well, the sort method in the collections class expects objects to implement the interface Java lang comparable, and what that does is it forces subclasses to implement the compare to method, and the compare to method says how you compare objects. So if we say that the cow class implements the comparable interface, then we have to provide an implementation of the compare to method. This @ override above it, by the way, I'm not sure you've seen that before in lectures. It simply labels the method that follows as being an overriding method. And that helps in the sense that if you did something silly like making a typo in its name, then the compiler would notice that it wasn't actually overriding anything and would tell you so. So it's helpful, partly as documentation and partly to catch errors, as so often. One thing you might wonder is, what is that comparable angle brackets cow going on there? We talked about the comparable interface, but why is it parameterized on a cow type? Well, the reason is, if you look at the signature of the compare_to method, the argument that compare_to takes is an object of type cow, not an arbitrary object of some other kind. It's important that the two objects we compare should be of the same class. In other words, it's a binary method. And the way that works in Java is that we say the interface is going to be parameterized on the type of things we want to compare it to. This is slightly weird, but binary methods in object orientation are quite an interestingly tricky topic. This is just how it works in this case in Java. Okay. What is compare_to expected to do? It is supposed to take two objects, the recipient and the argument, and if this, that's the recipient, is less than the other, it's supposed to return a negative number. If it's greater than the other, it's supposed to return a positive number, and if it's equal, it's supposed to return 0. And this is according to whatever ordering you have decided as the writer of the class that's going to implement compare_to is the relevant one for your application. So here's one thing we might do, implementing comparison by size. Another thing we might do is this. You might say, I'll be clever, I'll do it in one line. And this actually has the same effect, but it's kind of bad style. Why is it kind of bad style? Well, because the reader, you've saved 2 lines of typing, but the reader now has to really think about this to check that your expression does in fact give the right values in each case. So, as the writer of code, you should generally be prepared to spend a few extra minutes typing if it's going to save readers a few minutes reading every time they look at your code, because probably there are going to be more readers than writers of your code in the end. And also, although I think this is a less important reason personally, because integer overflow might happen and might give you a problem here. Okay. Something that's often useful to know is that you often don't have to implement your compare_to method from first principles, although of course you can if you like. You might like to use the fact that Java's boxed primitives, that is, things like the integer class which wraps up a primitive int type, already have compare methods. These are static methods on the class, so the way we've got it here is that there's a static method in class integer called compare, which takes 2 objects of class integer and returns our positive, negative or 0 answer in the way we expect for the compare_to. So that saves us some effort. Also, just in case it's more convenient sometimes, many of these classes in the API, including the boxed primitives and string, implement the comparable interface already. So you can simply appeal to their implementation of the comparable interface when you want to implement your implementation of the comparable interface, like that. Okay, let's see some more examples. As usual, have a look at this. When you think you know what it prints, proceed. This doesn't compile, because at the top we have a thing called an interface, drivable, but it's attempting to implement a method, and interfaces can't implement methods. That's not allowed. What about this? This prints polar power. This works fine if you think about it. So, in summary, abstract classes can be used to implement common behavior without allowing instantiation, as we saw. So an abstract class is the opposite of a concrete class. A concrete class is one that can be instantiated. And you can use an abstract method to say, I'm not going to tell you how you must implement this method, but you must implement it somehow. Interfaces are one step further. They allow you multiple inheritance in the sense that a class is allowed to implement multiple interfaces even though it may only extend one class. However, the downside, which is necessary in order to achieve this benefit, is that an interface cannot implement a behavior. And in Objects First, Chapter 12 is where you would look. And I think in the Java tutorial you're still in Chapter 5, but see.